Okay, so we're going to be doing Study Guide 1. This is Chapter 4. Chapter 4, Study Guide 1, problem number, it's the first free response question. And I was asked to do parts C and D. So for part C, we're trying to figure out when g prime of x is not defined. And g of x is defined to be the absolute value of f of x. And so if we just draw g of x, we can see that if f of x is above the x-axis, then g of x would be the same. But then down here we've got f of x being below the x-axis, and so therefore g of x would then be above the x-axis, because the absolute value of any number makes it a positive number. And so if the y values on f of x happen to be negative, then the y values on g of x equaling the absolute value of f of x have to be positive. Okay, and so this point down here at 3, negative 40, the y value then, instead of being negative 40 on g of x, would be a positive 40 on g of x. And so we're going to aim for that spot right up there, just like that. So that's I suppose a decent drawing. And so then, since that's g of x, we're looking where g prime is not defined. Well, g prime we know is not defined where we have a sharp point. We can see that here. We can prove that by doing a lot of math, or we can just say, hey, that's a sharp point right there. If you had to show that that's a sharp point, you would show that the derivative from the right is different than the derivative from the left. So you'd have to break up that function into two pieces. And then and you'd say that's a sharp point. So we'd say that f of x, or g prime of x, is not defined when x is equal to negative 2 because of this sharp point. Okay? And then part D, we're trying to figure out all values of x where g of x is concave down. So what we really need to figure out here is the inflection point. We can see that g of x would be concave up right in here. We can see that, and so we can, don't have to worry about that. But we can see also that g of x is concave down right in here somewhere, right in here, and I'll keep erasing that stuff, but you can see g of x is concave down, and somewhere along the way it makes g of x makes that transition into concave up. Okay, so we look at f of x, and just to give you a little bit more information on why we know that g of x is concave up here, because f of x is a third degree polynomial. Okay, we can see f of x. Let me do this in big dark purple. We can see f of x looks like this. We know that polynomial functions are nice and smooth. We can see that f of x has some sort of an inflection point somewhere right around in here, and we know that g of x then would have that same inflection point right around in here. Okay, but we also know, let me back up, we also can see that there's a change in concavity right in here, right there where x is equal to negative 2. So we know that when x is equal to negative 2, we have an inflection point. And then the graph of g changes concavity just to the right of that inflection point. And so it transitions from concave up to concave down. And then again, that value, somewhere right in there, right around 0, we're going to find that g of x has another point of inflection. Okay, so how are we going to figure that out? Well, let's just figure out what the point of inflection would be for f of x, and we can use that same x coordinate, or that x value, because we can see that g of x is just a reflection in that area about the x-axis, and so the point of inflection would be the same x value. And so I took the liberty of multiplying f of x out, so we can see in the upper right hand corner of your screen here that f of x is this third degree polynomial, which I already said. Therefore, f prime of x would be equal to negative 6x squared plus 6, and f double prime of x would be equal to negative 12x. And f double prime equals 0 when 12x is equal to 0, or when x is equal to 0. So when x is equal to 0, we can see from the graph that the inflection changes, or the concavity, I should say, changes from concave on F, concave up to concave down, right there at 0. And therefore, the graph of G would change from concave down to concave up, right there at 0. And so we would have the G would be concave down from only in that one area, only between x equals -2 and x equals 0. So that's our answer for part D. Okay, and here's our answer again for part C.